Astronomers have identified a new kind of supernova we never knew existed. This is by Brian Koberlin, Universe Today on Science Alert. We often think of supernova explosions as inevitable for large stars. Big star runs out of fuel, gravity collapses its core, and boom. But astronomers have long thought at least one type of large star did not end with a supernova. It's known as Wolf-Rayet stars. They were thought to end with a quiet collapse of their core into a black hole, but a new discovery finds they might become supernovas after all. Wolf-Rayet stars are among the most massive stars known. They are at the end of their short lives, but rather than simply running out of fuel and exploding, they push out their outer layers with an extremely powerful stellar wind. This produces a surrounding nebula rich in ionized helium, carbon, and nitrogen, but almost no hydrogen. The surface temperature of the remaining star could be over 200,000 degrees Kelvin, making them the most luminous stars known. But because most of that light is in the ultraviolet range, they're not particularly bright to the naked eye. Even with the outer layers of the Wolf-Rayet star cast off, the central star is still much more massive than the Sun, so you'd figure it's only a matter of time before it becomes a supernova. No matter how far up the periodic table fusion occurs, it will eventually run out of fuel, leading to a core collapse supernova. But we still can see the spectrum of elements within a supernova, and we've never seen a spectrum that matched a Wolf-Rayet star. As our discovery of supernovas become commonplace, some astronomers began to wonder if Wolf-Rayet stars had a quiet death instead. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box. The idea was that they would cast off enough outer layers that the remaining core would eventually just collapse directly into a black hole. No giant explosion needed. A silent death to a massive star. This latest study shows that at least some Wolf-Rayet stars do become supernovas. The team looked at the spectrum of the supernova known as SN 2019 HGP, which was discovered by the Zwicky Transient Facility, ZTF for short. The supernova spectrum had bright emissions, light indicating the presence of carbon, oxygen, and neon, but no hydrogen or helium. And when the team looked at the data more closely, they found these peculiar emission lines were not caused by elements of the supernova directly. Instead, they were part of a nebula expanding away from the star at more than 1,500 kilometers per second. In other words, before the supernova occurred, the progenitor star was surrounded by a nebula rich in carbon, nitrogen, and neon, while lacking the lighter elements of hydrogen and helium. The expansion of the nebula must have been driven by strong stellar winds. This matches the structure of a Wolf-Rayet star extremely well, so it looks like SN 2019 HGP is the first example of a Wolf-Rayet supernova, and since then, similar supernovas have also been detected. Because this supernova was identified by spectra of the surrounding nebula, it is not clear whether the explosion was a simple supernova or whether it was a more complex hybrid process where the upper layer of the star exploded while the core collapsed directly to a black hole. It will take more observations to determine the details. What's clear is that at least some Wolf-Rayet stars do not go silently into the night. This article, originally published by Universe Today, is on Science Alert. Please leave your comments, and thank you for your support.